2.4, write equations of lines. Mostly going to be talking about point slope form, but we kind of have to talk about how it fits together with the rest. And to do so, I really want to start with a little geometry, just a little bit. And then how do you know which equation to use if I ask you to write the equation of a line? What kind of information might you have that you can use to write the equation of a line? And then what might you end up with? So I promise it'll just be a little bit of geometry. So what do I need to write the equation of a line? We didn't talk a lot about equations of lines in geometry, but we talked a whole lot about lines. And we learned that you need, maybe you learned this in Algebra 1 too, you need 2 points, and then you can make a line. Through any 2 points, there's exactly only, if I can get this right, 1 line. So if we were in the coordinate plane, there would only be 1 equation for that line. It could look different. We could write the slope of it. We could find its y-intercept. We could write it in point slope form, slope-intercept form, standard form, but it's all the same thing. It's like just wearing costumes, right? So how can we know what we mean when we want an equation of a line to be written? Well, it's kind of like cooking. If you want to make cookies, sometimes you want to make chocolate chip cookies, so you go to the store and you buy the chocolate chips, and if you want nuts, you buy nuts, and you make sure you have flour and brown sugar and vanilla and eggs and all that good stuff. And then sometimes you just open up the cupboard and you go, I want to make cookies. What do I have? And it's like, oh, I have peanut butter. Okay, I guess I'm going to make peanut butter cookies. So that's the way it is with equations too. So part of the question is, what do you want to end up with? But really the bigger question is, what do you have to work with? Okay, so what do you have? That's really where you have to start. You got to know where you're going, but you really have to start with what you have. Then we'll talk about the name of the equation we can use, the name of the equation that you can use based on what you're given, what you have to work with. And then we'll talk about the equation itself. And then based on the equation, what's it good for? What does that get us? What can we do with it? What do I mean by all this? Well, I don't care what you want to end up with, but if all you happen to know are 2 points, we said 2 points can get you the equation of a line. So you can get the equation of a line out of 2 points, but not immediately. If you know this information, that doesn't make sense. If you know this information, what have we done with it in the past? Well, all we can do with that is find the slope. Right? Equation for slope, we can plug that information into here, and it gets us the slope. Okay, what's that good for? Well, it gets us the slope. Sometimes that's it. We could graph it, but we don't usually. But we can take that slope and do more with it. All right, so from here, we can then, if we want the equation line, use point slope. So what is point slope? Well, what do we need to use point slope? Conveniently, we need a point and we need a slope. So if we already found the slope, we have the slope, and we obviously have at least 1 point. I say conveniently because I like the fact that they named it point slope, because what do you need to use it? You need a point and a slope. So what does it look like? Well, it's very closely related to the formula for slope. Right? So the thing is, we don't usually stop with it. You might later in math, but what's it good for? It's usually just a temporary stop. On the way to writing either slope-intercept form or standard form. Because the default, if I say write the equation of a line and I don't tell you what form, I mean slope-intercept. That's kind of our default, right? And so later in math, if they say write the equation of a line, they're going to be fine with you stopping at point slope. But at this point in Algebra 2, we generally mean slope-intercept. So what do we need to write slope-intercept form? Well, we need a slope and we need a y-intercept. So if we have that to start with, that's the easiest one of them all to write because that's usually where we want to end up. So if I give you the m and the b, you're done. You just plug in the m, plug in the b, and you're good. So what's it good for? What does it get us? What do we usually do with it? Well, we often use it to graph it. Right? It's great for graphing. It's the default, right? Meaning that's, if I don't say anything else, this is what I mean for write the equation of a line. Now that doesn't mean I can start there if I don't have the slope and the y-intercept. It means that's where I'll end up. Well, how can I end up there if I don't have the y-intercept? Do all those other things. And that's what we're going to practice on this video. So standard form is a little different. I'm going to kind of go about this in a different way. This is standard form, and you can see it just doesn't match up with the rest. The rest all kind of go together. And standard form is like off by itself. What do we need to write standard form if they didn't give us standard form? Well, we need slope-intercept form. It's easy to turn slope-intercept form into standard form or standard form into slope-intercept form. We can graph it, but we already saw sometimes it's kind of ugly. But if the x and y intercepts are nice, we can graph it from that. But often it's going to get turned into slope-intercept form, or vice versa. All right, beautiful. Okay, y minus y sub 1. Well, y sub 1's going to get substituted. X sub 1's going to get substituted. That's the point in the point slope form that gets substituted. And the m's going to get substituted. So the blue stuff's all going to stay, and the red stuff's going to get replaced. So if I give you a slope and a point, we're going to plug those green things into those red spots. So I'm going to write y minus what? Well, my 5 is my y term. And then substitute the m, so that's 3. And then x minus, my x term is negative 2. So if I have a minus or a negative x or a y, we're always going to have to take care of that minus minus, and it's going to be a plus. So that's point slope form. Very occasionally you might be told to stop there, and I guess later in math you probably will, but for us that's not just where we're normally going to stop. But let's do that so we know that that's kind of one possibility. Normally we're going to keep going. And so how do we get that into slope-intercept form? Well, it's always going to be the same two steps. Distribute. And then the only thing that's in the wrong spot is that 5. So every time that constant that's on the left is going to have to move to the right. So we're always going to have to either add or subtract, depending if it's positive or negative, the constant, the number without a variable, to move it to the right to get the y-intercept. Okay, so that's slope-intercept form. And so more often than not, that's where we're going to stop. But sometimes we're going to need to turn that into standard form. And it's always the same step. Sometimes there's an extra step. So on this one, I'm just doing a simple example. I'll do more examples on another video. So every time we're going to move the x term to the left. The only thing that's wrong with that is that the x is on the right and it needs to be on the left. I'm going to go ahead and put that positive there for the y. So it would be negative 3x plus y equals 11. And that would be standard form. Sometimes standard form, they want to make sure that a is positive. Again, standard form is the one thing that's not positive. So you might see that with all the signs reversed to get a positive. So I just multiplied everything by -1. But that's the basics. So we talked a little tiny bit about geometry. How do you know which equation to use? It depends on what you've got. And how do you know what to end up with? You've got to read the instructions well. And so usually it's not too hard to turn one into the other, but it's all about what you're given.